Hello guys, welcome back to another tutorial. In this tutorial, we are going to talk about Li-fi. So what is Li-fi? So Li-fi stands for light fidelity. So Li-fi is a wireless communication technology which uses light to transmit data. And I must tell you that it's one of the most powerful and fastest communication technology, wireless communication technology now used today, and it is about 100 times faster than the Wi-Fi. So with Li-Fi, you can have data transmission in gigabits. So this is powerful. So first of all, Li-Fi is powerful. It's fastest, and now let's just talk about how does it work. So basically in Li-Fi, we use light to transmit data. Since we are using light, so these LEDs are mostly used in Li-Fi. So we are going to use this LEDs over here, this LED and this LED over here, and both are 12-volt LEDs that we are going to use to transmit data. So what is the basic principle of Li-Fi? So the basic principle is very simple. We are going to transmit data since whenever we want to send a binary 1, we are going to turn on the LED, and whenever we want to send a binary 0, we're going to turn off the LED. But there are some modulation schemes followed, like Manchester encoding, the ook, and BPSK, etc., etc. But we are going to use the Manchester encoding method for this project over here. So this LED will be turned on and off at a very high rate that the human eye cannot detect it. And obviously, in most of the projects that I've seen on YouTube, is they are not very useful because the range is very small, and most of them uses LEDs, like a simple LED, 5 millimeter LED, like this one over here. So most of them do uses those LEDs, and the range is not very good, and the transmission speed itself is not very fast, and also the light that is going to transmit the data is going to be flickering. So with all those disadvantages, I decided to take this project on a next level. So this is going to be it. And in this project, the best thing about this project is the range is very high. You're going to transmit data from about 10 to 15 feet, and I'm going to use this LED over here for 1 meter range. It's about 3.2 feet. So we are going to use this LED for 1 meter range, but you can increase the range as well. It's possible 10 to 15 feet is possible with these circuits over here. So let's just skip that detail, and let's just talk about these PCBs over here. So first of all, we have a transmitter circuit over here that I have designed by myself. So this is the transmitter, and it's basically a constant current LED driver. It's basically a constant current LED driver. The LED is connected over here, and the input voltage is from 5 to 18 volt is going to be input from here, and this potentiometer over here adjusts the current. Since this LED over here requires 300 milliamps and this one over here requires 600 milliamps, so I have this chosen in the range from 0 to 700. So this is acceptable. So this is the transmitter, and the input voltage is again 5 to 18 volt, but since these are 12 volt LEDs, I'm going to input 18 volts. But if you want to connect a single LED like a 3.2 volt LED, so you can do that as well, but the input voltage will be 9 volts. So if you're going to input 9 volt over here, you can connect a single 1 watt LED. And if you're going to connect two LEDs, you can connect 14 volt over here. But since this is the 12 volt LED, you must have to have the input voltages from 16 to 18 volts. So this is the transmitter, and uh, this uh, this are this is the receiver, which is basically a light detector circuit. So this is going to receive the light when the light incident on these photodiodes over here. They produce currents, which is going to be detected by this amplifier over here. This is basically the whole circuit is basically a trans impedance amplifier. And what is a basically trans impedance amplifier? It's basically a current to voltage converter. So the current is produced by these photodiodes will be converted into voltages. So this circuit over here can have 5 to 9 volt input voltage range. And as I told you that this PCBs can give you range of about 10 to 15 feet. So you can increase the range. I am going to use it on 5 volt, since I am going to use 1 meter. But if you are going to increase the range, you must increase the voltage. With 9 volt you can have 10 to 15 feet range. So I'm going to use it on 5. So this is the light detector, but this is the single stage. The second stage will be this circuit over here, which is going to take the voltage output from this um, this light detector and convert it into digital from 0 to 5 volts, because Arduino can detect digital voltages. It's digital inputs. So for that we need to convert it into digital. But it's fine, you can all directly connect this to analog pins. But I'm not gonna do that, because we are going to use Manchester encoding as well. So this is very very problematic, so we are not going to do that. So that's why we are going to use this module over here. So these two modules together will produce the output voltages in digital form from 0 to 5 volt, which is going to be detected by the Arduino, and Arduino will process the data received by this LED over here and decode it and show it on the LCD. So this is the 16 by 2 LCD which we are going to use, and here it is this circuit which is going to be, this LED will be connected over here, and the potentiometer and this circuit. So this is another light detector, but it is not an amplifier. It's basically a comparator. So this is simply a comparator circuit with some different circuitry, but it has a good range. For 1 meter it's perfectly fine, but I'm not gonna do that, because this is not very not very reliable. You can say that it's not very reliable, because the data is transmission is very fast, but it's acceptable. Acceptable. I have both. I've used them both with the same Manchester encoding algorithm, and both works perfectly fine. But this gives me a higher range, while this one can't. So this is it. So these two Arduinos, one Arduino will be connected on the transmitter side, and another one on the receiver side. Okay, now so everything has been set up. Now let's see how the system works. So let me show you this. This is the power cord where we can connect the 220 volt power supply. This is the on off switch, and from here we can connect the double-sided PCB, double-sided USB cable. We can connect it to the desktop or laptop, and we can transfer data from there. So let me show you what's inside. Firstly, I need to turn on the system. So as you can see, this one is the Arduino. There is a transmitter from the Arduino, the LED driver, the LED, and Same is here. Another Arduino for receiver, the receiver light detector, receiver circuit, and one more thing is this one here, which is the LCD module. So this is everything we have got. So now let's see that in action.